All right, thank you for the lovely introduction, and thank you for inviting me to be here today. It's great to meet all of you. My talk today, When Visualization Meets AI, Exploring Opportunities, kind of tries to tie together much of the research that I've been finding myself doing over the last several years, starting from when I was at Tableau and now moving into my position at the Roux Institute, where more and more I'm finding that my work in data visualization, which is my core background, is bridging with AI in various ways. So I thought that today I would share some of those with you and try to tie a few connections to biological and medical applications. Okay, so AI, as we all know, is starting to pervade our society. We're all encountering it all over the place, especially with the advent of LLMs in the last couple of years. And so more and more it is filtering into everything that we do, and that includes very much the domain of data visualization, which is where I have spent the bulk of my time. Now, the way that I think about it is that AI and data visualization meet in two core different ways. The first is visualization for AI. And by this, I mean that AI models, if we want them to be used by people, we need some kind of interface to them. One of the possible interfaces that we can build for AI models is through data visualizations that can sort of open up the window into what those AI models are doing and why they're making decisions and so on. So Viz for AI is all about AI kind of being the core thing you're interacting with, but you're doing so through a data visualization. Now I'll get to that part later in my talk. The second major way that they intersect is through AI for visualization. And here the idea is that maybe the core thing you're interacting with is a data visualization or a visual analytics tool, but there's some AI happening in the back end to facilitate that interaction, to make it easier to interact with your data, help you find patterns in your data, or to just somehow make that interaction smoother, more transparent, easier in some way. And so on my talk, I thought I would kind of touch on both of these topics, but let's start with AI for Viz. And here I want to touch on two different kind of facets of AI for visualization. The first one being Viz recommendation, and the second one being natural language interaction, both of which I've spent some time working on over the past several years. So let's start with Viz recommendation. One of the core challenges that people encounter when they're working with the data set using visual exploration is the question of kind of where to start. What's interesting in my data? I might not know. If I know, then great. I can probably kind of get to a visualization that might help me look at the details and answer questions. But if I don't know where to start, it can be very difficult, especially if my data set has many, many different dimensions and so on. It also can be hard for people to know what visualization might be best for their data. Visualization expert has a lot of kind of rules and guidelines that they can follow to produce a data visualization. But for everyone else who may be a domain expert, it may be less obvious. And even for visualization experts, it's a bit of an art and an exploration and a little bit of trial and error to get to the visualization that might answer your question. And so these are questions where AI can help. And the core way that AI has been helping in this space is through Viz recommendations. Now, Viz recommendations is an area that's been around for quite some time. There are many, many tools, for example, the Voyager tools out of UW, where the idea is, if you've got a data set, the system can go and help you find interesting patterns in that data, recommend those patterns, so recommending data attributes and values that might be interesting. And it can also recommend visual encodings, ways in which you might represent those data attributes in a chart that reveals those interesting trends. And of course, there are more than then the Voyager tools. This has been a rich area of research for some time. I do want to highlight one particular tool, not my own, but coming out of my lab, which is GenoRec by Aditya Pandey and Michelle Borkin. And the reason I highlight this one is because it's about Viz recommendations applied to genomics data. And so same idea, you've got some genomics data, you can load in, you can express what your interest is in the data, what your goal is, and then the system will recommend some potential visualizations that might be useful for answering your questions. My own work in Viz recommendations has looked at, coming from this paper that I worked on at Tableau, the idea here was to look at how we might help users to take a next step from where they are right now. So when you get a big data set with a bunch of attributes, tools like Tableau or this sort of a model, prototype that has a similar idea, allow you to kind of pull attributes onto different shelves, whether that's the x-axis, y-axis, color, and so on, but it leaves it entirely up to the user to figure out which attributes might be interesting. And so our thought was, well, maybe we can help people by giving them a next step from where they are, and not just one, but several possibilities that might help them figure out where to go. So if your current view is this histogram in the middle, the system will recommend you several other views that essentially take one step away from where you are. And it organizes those views into facets based on what kind of step you're taking. So at the top here, these are going to be filtering the current view by something. And at the bottom, it will be enhancing the current view by adding one additional variable. And we have some metrics of interestingness that help to to rank the different possible steps you could take by some notion of what might be interesting, what might show a pattern. So as one example, here we're showing a visualization of cost of education by average faculty salary in the current view on the left. And the blue box highlights one possible next step, which automatically found another variable which cleanly separated this view into two different clusters. And this was done by adding a single variable about whether the institution was private or public. And so here you can see that the system is maybe helping the user find something interesting in their data by suggesting a next step. So our contribution here was in looking at how these kind of next step views and organizing them into facets might help people or not to explore their data. And when we did a user study with this tool, we found that people used recommendations for a couple of different purposes. The first was when they were just stuck. They didn't know what they might do next, and so they would explore the recommendations. And the second was to rapidly explore the data much, much quicker than they could have by kind of randomly poking around. They could rapidly visually scan a bunch of possible views for insight and then pick ones that seemed interesting and kind of go from there. And we found that when we compared having these recommendation categories to recommendations that weren't categorized, the categories help people to come to a sort of richer and higher utility exploration, enabling them to get more insights quicker and enabling them to more quickly understand why a view was being recommended. There were, however, many different sort of individual differences in how people used them. Some people took a very recommendation-oriented strategy where they did almost nothing manually. They would actually just create a chart and then scan the recommendations for something that looked interesting and go there and then scan the next set of recommendations and continue that way. Others took an almost entirely manual approach and just ignored the recommendations almost altogether. And then other people took a more balanced approach where they would answer some questions manually, but when they weren't sure what to do next, they might scan or pick some recommendation. So all the research in Viz recommendations shows that it's a really helpful way to guide visual analysis. But I think that there are still many kind of open opportunities where we could do more in this space. One is in automated insights. So one thing that Viz recommendations do is go off and find interesting stuff in your data. But typically, all these recommendation tools only find those things that are in your data set, your enclosed data set. What might be more interesting, or at least more novel, is to go beyond what's in the data. So if there's a pattern in the data, are there outside related data sets that might help explain it? Could we go off and search a data repository to find those other things that might be connected, that might help to interpret my data insight? Could we identify things going on in the world at the time that might explain why something happened? You know, if we see a big dip in a value in the 1940s, maybe that was because of World War II. Maybe without the data set knowing that, maybe the system could go off and find that information and inform the user. Another thing that we could explore is personalized recommendations. So most recommendation systems give the same recommendation to everybody, but perhaps these systems could learn from the individual user what parts of the data are interesting to them, what kinds of questions they tend to ask, or what types of visualizations they tend to prefer. And perhaps it could kind of customize the recommendations in a more personalized way. And a third way that these kinds of tools might be further adapted is to enable smart onboarding and to build literacy, visualization, and data literacy in the people using them. So a common problem that we see in visualization is that novice users who are brand new may not know where to start, may not know how to build a good visualization, may not know what questions to ask, and perhaps these kinds of recommendation systems could be deliberately designed to help them build those kinds of literacies, not just to help them in the moment, but to help them grow and learn over time. All right, so that's the domain of Viz recommendation. Another way that visualization can be enriched through AI is by making the interaction with the visualization more natural. So the general challenge would be, how can we make answering data questions easy, natural, and simple? And while Viz recommendations are one way to do that, there are other things we could employ here. And the one that I've been working in for quite some time is natural language as a means of interacting with your data. So even back as early as 2010 or 2011, I had done a Wizard of Oz study where we had people describe the question that they wanted an answer to, and then we had a wizard in another room who would build the visualization and then show it to them. And what we noticed in that study back then, even though it wasn't our goal, was that people could express what they wanted in English much more easily than they could by kind of picking and choosing data attributes and putting them into a visualization tool and producing a chart. So even back then, it was clear that maybe using natural language as a way to interact with your data might be a promising direction to help people do so more easily. And so when I joined Tableau a number of years ago, we started on a journey to start to build natural language interaction tools for your data, with the idea that you could ask a question and the system would then search the data, find the right things to show, and produce you a chart. So there's two examples on this slide. The bottom left, the user has asked in a data set about housing to show townhomes less than $1 million in Ballard, which is a particular area of Seattle. And the system has produced a map showing a bunch of houses as little dots and some associated charts about the prices over time and so on. On the right, the user has asked for countries with whooping cough cases, and the system has produced a map showing those different countries and the prevalence of whooping cough. But this work all started with a combination of some Wizard of Oz studies where we had a human in the back end faking the response to the user's queries, and then a series of prototypes where we ultimately kind of figured out how to make this work. And then ultimately this was shipped in Tableau's, as Tableau's feature called Ask Data, which is in Tableau server today. More recently, along this line, I've been working in the area of visualization chatbots. So here again, the idea is that maybe you could interact with your data in a nice way by using natural language, but in this case, the modality of interaction is more like a chatbot where you kind of ask and get answers, and the answers aren't just visualizations, they might also be text or voice responses. So my first foray into Viz chatbots was work done with Marty Hurst, where we asked the question, what kind of answers would users want in a data chatbot? Would they want to see charts at all? And if they wanted to see charts, how complicated a chart might they want? So just one example shown here, we have different answers to a question about Olympics data where the user is asking, are there more events in weightlifting or Taekwondo? And one option we explored was maybe they just want a text answer. Then we thought maybe they want that answer in text and in a chart. And then in the third case on the far right, we added more context information to the chart. So instead of just showing weightlifting and Taekwondo, we showed all of the other kind of top-ranked sports in terms of number of events, thinking that this might give more context to help the user understand their answer. And then we ran an online experiment where we explored user preference to these various answers that a hypothetical chatbot might give. What we found was a mixed bag. Roughly 40% of participants actually didn't want to see a chart at all. They said, no, just give me the text answer. That's good, clean and simple. But among those 60% or so who did prefer to see a chart, they pretty overwhelmingly preferred the chart with more context. So the one in the middle here as opposed to the one on the right. And so this suggested to us that one way that data chatbots could be kind of cooperative in helping users to answer their question is by providing more context than the user explicitly requests in their question. Continuing along this theme of work in Viz chatbots, I worked with Vidya Settler on actually implementing some working chatbot designs. We started here again with the Wizard of Oz study where we faked how the chatbot would interact, and then we went on to build a number of prototypes. And we were looking at different variations in how a chatbot might interact with the human. So we mocked up several different examples. One was a chatbot that was built into the messaging tool Slack. So this was entirely text and visual based and could use the threading feature in Slack to kind of organize the conversation. Another was a pure voice bot. We were curious what would happen if you didn't have visualizations at all, but you were trying to interact with your data by voice. So this is represented here as text, but this was actually a voice-only interaction. And then we had a voice plus display bot where we used an iPad to mock up interacting with a tool like the Echo Show or similar devices that have a screen associated with them. So let me just illustrate a couple examples of what these interactions looked like.
Now let's look at some sample interactions from the studies.
So here the user is asking what was the distribution of ages of passengers on the Titanic, and they get an answer which they can then drill into.
How how many passengers are there?
Hold on, let me find your answer. 1,309 passengers were on the Titanic.
What is the youngest person on the Titanic?
Youngest person on Titanic was 0.17 years old.
I mean, of course, it's on here, but it doesn't make sense. Just like it's not natural. What would make it more natural? The youngest person is an infant or something.
Percentage of passengers in cabin class 1 survived.
Sure, getting back to you on this.
So what do you expect it to do here?
I expected to probably give me a breakdown.
61.92.
I mean, not breakdown, that's exactly pretty cool. Because I asked a specific question, right? So there's no quiz. Give me a breakdown of the percentage survived by class.
Here's your percent survived broken by class.
Okay, let's try something else. What was the average fare paid by the passengers? Great.
$33.30.
Now let's look at some sample interactions from the study.
Okay, so this particular participant in our study got a couple of responses from the chatbot that were just single numbers. And while he was actually okay with this, the majority of our participants didn't like those kinds of super simple answers. They wanted the bots to be a little smarter in their answers. So they wanted the bots to do things like automatically filter null values out of the data before giving the response. And they wanted the bot to provide context to these kinds of fact-finding questions. So instead of just giving an answer of 62%, better answer was if the bot did something like 62% of class 1 passengers survived when compared to 43% in the other classes. And this kind of added context both helped to give an explanation of what was going on, but it also confirmed that the system had truly understood the question the user was asking and wasn't giving an answer to some other potential question. So in this way, they wanted the bots to restate elements of the question in the answers. They also wanted the bots to be smart in understanding follow-up utterances. So if I asked a question, got a visualization, then I'd like to be able to ask a simple follow-on question without restating everything to recreate that chart. I just want to maybe modify it a bit, add another attribute, filter it, something like this. Similarly, people wanted easy ways to repair and refine the answers so that if they got an answer that they didn't quite expect, which wasn't the answer to their question, they could adapt that rather than having to start over with a new prompt. So from there, we went on to actually implement several working data chatbots, and I'll just share some examples of what those look like.
We then conducted a second study to test how users interact with working chatbots. We implemented the chatbots in Slack, showing widgets and supporting conversation threads. We also implemented the Echo Show chatbot that can take verbal commands and display charts with text along with audio responses. Finally, the Echo chatbot is completely voice-based. Here are a couple of sample interactions with these chatbots.
So the user types show me expensive varieties of wine, and they get a chart, which then they can explore through some widgets.
Show me the wines by location.
The most expensive wineries are located in the United States.
Show me the most expensive varieties.
The most expensive variety is the Cabernet Sauvignon.
We then conducted a second.
All right, so from all of this work, we learned that there were several ways in which we could make chatbots more intelligent and more cooperative through various design attributes that we could add to them. People really enjoyed the threading and the interactive widgets in Slack to be able to explore further from where they are. and they enjoyed ways of being able to repair the response that they were getting from the chatbot with follow-on queries and with GUI widgets. So these features encouraged richer analytical inquiry, they kept people in the flow of the analysis, and they enabled a sort of back and forth multi-turn conversation. Okay, so natural language interaction with visualization has now been around for quite some time, but I still do think that there are new opportunities here. One is around expanding beyond natural language to multimodal interaction. And this is particularly true for situations where you have non-traditional displays or you're in physical environments. And I'll get to some examples in a minute. But using more than just voice or text, maybe using voice plus pointing, for example. We can also imagine visualizations that adapt either to the user, to the device, to the context, and so on. So let's take a medical example. Imagine that you've got a nurse working in a hospital situation who needs to use visualizations on the go. Here, the challenge is that the nurse is not someone who's going to be sitting down at a display necessarily and interacting with their data for an excessively long time. They might want answers anywhere in the hospital. They might be interacting with a patient where their hands are busy, and there are many complications associated with this. So here we could imagine it would be great for a nurse to be able to use voice interaction to interact with their device. But they could also use sort of multimodal interaction where it's not just voice, but also pointing. Show me the information about that patient, for example. We could also imagine that the visualizations might adapt to the device that's ready to hand, so that if the nurse is wearing a smartwatch, the information could be delivered there if they're on the go, but could be delivered to a large screen display in the room if there happens to be one available and they're in front of it. This kind of work could similarly apply in biological laboratory situations. So imagine a smart biological laboratory workbench where the biologist is busy working with their hands. There's lots of things happening. Here's an opportunity for us to use voice-based interaction to more easily bring up data visualizations on the fly in the moment, rather than waiting until you say, go back to your desk. All right, so far I've been talking about AI for data visualization, and that's kind of one piece of the puzzle. But in my more recent work, I've been looking at the other side, using visualization as a window into AI for both, and this can be useful for both AI model creation and debugging, and also for AI model use. So AI applications, I'm sure you've been hearing about many, many of them throughout the rest of this conference. AI is more and more being used in biology and medicine for things like drug discovery, medical outcome prediction, diagnosis, protein structure prediction, sensor monitoring, and many, many more applications. And of course, in all of these situations, we need some way for the end user or the model builder to be able to understand their AI model. So this is where I think visualization has a big opportunity to provide that window of transparency. The key problem here is that many AI algorithms are inscrutable. And then the question becomes, well, how can we deal with that? And what are the ways in which visualization can expose some transparency so that we can understand what's going on? Moreover, AI algorithms are not always trusted and shouldn't always be trusted. And I think that visualization can play a role here in helping the user kind of calibrate their trust. So there's been a lot of work in this space, application of supporting model builders and debuggers. So I'm not going to delve too deeply into this, but I will give one example coming from Daniel Kerrigan and Enrico Bertini in our lab, which is slice lens. So the idea of slice lens is that it helps to guide an exploration of a data set for either model building or for model debugging, taking data that has labels as ground truth, and then showing different slices of the data set sliced across various different combinations of dimensions, and then showing the distribution of those labels within those different slices. So the colors here in the various plots show the kind of distribution of the different labels. And the system guides the user along the way by recommending different attributes that might be interesting and combinations of attributes that result in interesting label distributions. This is one example of a whole class of work that you can find in locations like the Viz Cross AI workshops. And I'd encourage you to explore this area if you're interested. My own work has gone more in the side of end users who want to use AI models to make decisions. So imagine a doctor or a nurse who is using an AI to help recommend treatment options. The AI recommends shock therapy. The user might question that idea. And what that brings up is this idea that AI models can't just provide an answer or a recommendation. They need to do a lot more than that. In addition to the recommendations, they need to provide a rationale for the recommendations, the uncertainty around the recommendations, and model properties and capabilities, like how was this model trained? On what data was it trained? What is the extent of its capabilities? Is the data I'm using within the same realm as that training data, or is it outside that realm? Who built this AI model? Can I trust them? Has this thing been certified? Who has it been certified by? And so on. And it's all of those extra bits of information that help users to calibrate their trust in the model and decide whether it's worth considering the model's recommendation or not. So along these lines, I've been working with medical collaborators and AI experts who are mostly interested in medical prediction problems. So here, the goal of the AI is to predict either the future disease state of a patient, a future outcome of a patient, or to recommend a course of treatment suitable for this particular patient, and so on. So this is very much in the realm of personalized medicine. And our first foray into this direction is a tool that we called Sepsis Lab. And this was about predicting sepsis infections in patients in the hospital. So the idea here is that, in the left side, we have a list of patients. In the middle, we have typical electronic health record information about that particular patient, including lab test results and so on. And in the right-hand side, we have our prediction of a risk score of this patient developing sepsis in the near future. So the gray chart shows the risk score with some uncertainty around it because we're not sure how accurate this recommendation is. And we can also recommend lab tests that the clinicians might do to help them narrow down that uncertainty range. So because the patients in the hospital, there are many possible lab tests that could be done that they maybe haven't had done, there are blank spots in their data. There are gaps. And we can predict which gaps are most useful to fill that would most reduce the uncertainty of them going into septic shock, and then recommend those lab tests. So at the top here are the recommended lab tests with a score, a ranked order score of which ones are maybe most important to do that would narrow the uncertainty the most. The user can pick some of those lab tests, order them from the interface, and when you pick those particular lab tests, we then show in the red future prediction how much the uncertainty is likely to narrow down. So the goal here is to provide an actionable choice that the clinicians could make to help them make a further decision. My ongoing work in this space is with cardiothoracic ICU at Maine Health, which is our local hospital system. The cardiothoracic ICU is where all patients who've gone through heart surgery go to recover. And there are many, many adverse events that can happen to these patients. They are very, very sick. And these adverse events can come on suddenly and can be very costly in terms of both patient health and dollar cost to the hospital. And so, what we would like to do in this project is to be able to predict adverse events like heart failure, cardiac arrest, sepsis, and so on for these patients quite early on so that the clinicians could intervene earlier. So we have we're collecting real-time data feeds about the patients, their vital signs, their electronic health records, and so on, feeding those into a warehouse where my AI colleagues are deploying predictive algorithms that can predict, I believe, 9 different risk scores for 9 different outcomes. And then our work is to devise an interface where we can feed that information along with the uncertainty around those predictions back to the clinical staff. Excuse me. So this is a project my team is working on right now. We just completed a field study in the cardiothoracic ICU where we were aiming to understand the population of workers who are there, the different roles that they have, and the environment in which we will need to deploy this interface. From there, we recognized several challenges. One is that these nurses in particular undergo a whole lot of alarm burden. I don't know if any of you have been in an ICU environment, but there are a lot of alarms ringing a lot of the time, and they were reluctant to add yet another thing, our predictor, which might be ringing more alarms. So we need to be really careful about the way in which we're going to present this information in that environment. They also undergo a ton of charting burden. The amount of effort that they have to devote to recording information into the patient record is substantial. And so our goal will be to integrate this in a way that the predictions, if they're going to be recorded into the permanent record chart, will do so automatically. They also talked a lot about trust and the things that would build their trust in an AI predictive algorithm like this. And one of those key things is that it had to provide clinical value that goes beyond what they would already know. So clinicians in these kinds of ICUs already have a lot of intuition and a lot of knowledge and experience that will help them make predictions about where a patient is heading. And our algorithm is going to need to demonstrate that it can accurately predict things that they would not have consistently already predicted before it's going to be kind of adopted and deemed valuable. So it's to be seen in a future clinical trial whether we can achieve that. But in the meantime, we are in progress of iteratively prototyping an interface, or actually a series of interfaces to our predictive algorithm that will show patient-specific views at the bedside, as well as kind of an overview state at the nursing station. So I think the core opportunity that this work and that other future work is trying to address is to enable explainability and decision support for domain expert end users, in my case, in the medical domain, but really this could be applied to any application of AI for domain expert users. Okay, so with that, I would like to thank my many collaborators, lab members, students, and others who contributed to the work that I presented here today. And I would be happy to answer any questions that you have. Thank you.
Okay. So thank you very much. It was very, very interesting. I have so many questions, but before I go into, I give the chance for the audience. Yeah, you can use the mic.
Regarding this data visualization and data recommendation, so the first part for your talk, aren't you afraid of the post hoc hypothesis testing here? The more they become, the more they know, they basically can search, dredge for data, for explanation of your experiment?
Yeah, I mean, it's true, but we're kind of targeting the domain of exploratory analysis here. So if you are truly doing hypothesis testing, visualization might not be the core way that you're doing that. It might augment your hypothesis testing, but you probably don't want to be using it to go dig for more hypotheses that you could then reveal. The kinds of applications that I'm targeting here are more exploratory uses of data, where you might not know what's there, you want to explore and see what might be there, and where the amount of data makes it impractical to kind of think up many, many questions, go dig at those questions. You would only be kind of poking at the space by doing that, and you would miss a lot. These kind of recommendations are meant to help you kind of get better coverage or know where to look into the interesting areas. Now, it's true, of course, that they are guiding users to subsets of the data and in consequence are ignoring other subsets of the data that sometimes maybe they shouldn't ignore, but at least we're helping them avoid just kind of poking randomly at the data and potentially missing big, interesting insights. I hope that answered your question.
Great talk.
Thank
Glad
you.
to see you. Yeah, so my question is, with complex data, and like what you were just saying is sometimes it's looking at one subset and not looking at the other one. Is there any way you can also visualize that? Because as a data scientist, I want to know what I'm leaving on the table as much as I want to know what I'm looking at.
Yeah, we did a little bit of work in that direction that we called data coverage visualizations. And what we had done was in a tabular data set, we would show a sort of list of all of the dimensions in the data set. And then we showed a little bar chart associated with each dimension for kind of how often you had put that dimension into a chart in your exploration. And so you could get a sense of, well, I completely missed all of these visualizations. Maybe I should go take a look at that. But I think there's more to do there because that only worked for a certain kind of data with a certain kind of interaction. And where you start to get into like Viz recommendations, where it might have been on the page, but maybe I didn't look at it, then that's harder to assess whether something that's been on the page but I didn't look at, is that coverage or not? If you get into things like network data, now I don't know how, now there's open questions about how to visualize coverage.
I had a question about, can you talk a little bit about your interaction with the physicians and nurses in the cardiac ICU? Are they coming to you with specific questions, or is it more like, here's the EHR data, can you help us find trends? What does that look like?
They approached us with the problem that they would like, they know that adverse events in the ICU are a big problem, and they would like to be able to predict them in advance so that they can intervene earlier. They also brought they had almost a semi-ranked list of those different adverse events that are easier or harder for them to predict. So, for example, acute kidney injury is one where they said, actually, this is a really big problem, and it's really hard for us to know until it's almost too late, right? So that's an example of one where it would be really great for us to target. Whereas sepsis, they said, is one where they tend to already know. So that's less valuable. But essentially, they came to us with that question.
Hi, thanks for the talk. I was wondering about the chatbots and the other types of visualization. Can the user have access to the underlying code behind it to kind of check for the trustability and also reproducibility to see what's going on under the hood?
We did not, in the studies and tools that we built, we didn't reveal any of the underlying code, but I imagine that you could, right? Especially with something like using now, say, ChatGPT plus code interpreter, which is a combination we've been playing with in the lab. Now you could start to expose some of the underlying code that the NL algorithm is generating. It will produce code in, say, a Vega Lite specification, which you could actually reveal to the user if you wanted to. But we didn't try. We exposed the underlying choices that the system had made as a series of widgets, graphic interface widgets, and an interpreted version of their question. So let's say the user asked, show me the most expensive wines. We would translate that into something like, show wine varieties by region, ranked by price, for example. So we would translate their perhaps vague question into our pseudocode language, show them that language, and then show them some widgets that they could use to adjust anything that we'd interpreted.
So I think I will hijack this question as well, because I was wondering about something along the similar lines. With your chatbots or the ICU, you have a problem that if you use some machine learning algorithms, you have the hallucination and these kind of things. There are methods that you can go into an explanation of what is the AI doing and so on, but that requires time. How would you, or would you have any ideas, how would you communicate this problem within the small view of a chat box or the pressure time, which is at the ICU?
I think that's a really good question, and I don't think I have a good answer for it yet. I think that's an open problem. In the ICU case, we are not using LLMs, so we're not using approaches that would hallucinate. We're using different kinds of predictors that are more statistically oriented. And so it's a little bit easier to ensure that there's not a hallucination going on there, and a little easier to ultimately certify such an algorithm for use in a hospital scenario where having these kinds of hallucinations could be quite disastrous. But that is a big problem, and I don't know the answer. I think it is something that we need to work on.
Hi, I was curious with the chatbot and the Wizard of Oz scenarios that you were working with. Did you find that people's preference for an answer related to the length of time they had to wait for that answer to be generated?
That's a good question. I didn't see a correlation there. It was definitely annoying with the Wizard of Oz cases that they had to wait. It was often on the order of like 30 seconds. And we would normally in our studies use that as an opportunity to kind of interact with the participant and ask them what they were expecting so we could elicit information. But doing that, having that kind of conversation with them sometimes meant that they'd even forgotten what they asked by the time they got their answer. So that was a little tricky. But I didn't notice that there was a difference in the actual answers they preferred given that time gap.
Okay, last question then.
Excuse me, very interesting work. Thank you. One of the curiosities that I have is that you have a lot of these chat interactions, which represent like a new data set to maybe be trained from. Has there been any effort to collect together the types of interactions that you've been developing on in order to improve other conversational models? And could I get at that data?
I haven't seen that specifically where there was a whole back and forth conversation collected. There have been efforts like NL Bench, for example, to collect a bunch of natural language queries that could be used to train models. So there are a few papers about that out there, and NL Bench is one of them. But I haven't seen work that collected whole conversations, and that would be interesting.